Network visualization. Humans are wired to find patterns, cluster, and changes in visually. So humans are what? They are wired to find the patterns and clusters and changes visually. Graph layout is a good layout. Every node is visible. For every node, you can count its degree. For every link, you can follow it from source to destination. Clusters and outliers are identifiable. So why is a graph layout good layout? Is because of these 4 reasons. They start with nodes randomly placed and iteratively move them around into better positions. As a result, running the algorithm multiple times will produce graphs that look different. They will often be similar but may be positioned differently. Also, each iteration helps to improve the layout. Eventually, the iterations make small or no changes. Some applications automatically run the algorithm for a fixed number of rounds, but other times the user can specify a number. Random layout. The nodes are placed randomly, as you can see. This is called a random layout and is often does not provide much insight into the structure of the network. Circular layout. Place all nodes in a circle and then add edges between them. So these are the edges and these are the nodes placed in form of a circle. Some circular layouts place nodes closer to one another when they are more closely connected. Next is the grid layout. Force directed layout. The layout is dynamic and determined by the connections between the nodes. These nodes that are more closely connected are laid out close to one another and those at a distance are shown far apart. So some are closely connected and some are distant nodes. Harel-Koren fast multi-scale layout available in NodeXL, designed to quickly lay out large complex graphs based on force directed layout algorithm, but uses optimizations in the underlying code to make the algorithm computationally efficient. For large graphs with thousands of nodes, generating a layout with many force directed algorithms can take a very long time. With Harel-Koren, it often can be achieved in few seconds, making it an ideal choice for larger networks. Whenever there is larger networks of graphs or complex graphs are there, this particular layout is more efficient. Visualizing network features. Network features like the edge weight, node properties, labels, and clusters can also be visualized. So even the network features can be visualized. Size, shape, and color. Categorical or quantitative attributes are particularly easy to show by adjustments in size, shape, or color. Scale issues, density, large graph properties. Filtering for visual patterns. It is often difficult to see any patterns in very dense networks. One way to compensate for this is to filter the networks when possible. So when the dense network is there, the best way to understand the patterns is by filtering the network wherever it is possible. Graph simplification. An active area of research in network visualization is graph simplification. Large networks are very common when working with social media. Problems of scale are common. Graph simplification techniques include grouping cluster of nodes into a single node and representing the edges between clusters as a single edge. So grouping the cluster of nodes into a single node. So suppose there are small nodes. I group them into a single node. So this will be grouped into a single node. And the edges will also, connecting the nodes will also be grouped into a single edge. Representing structural patterns as representing shapes or showing only a part of graph at a time. Tree structured network visualized into a tool called space tree. The nodes and the edges to the right of the first level are hidden but are summarized into a triangle. So this triangle you can see. Once you click on the triangle, the sub part will open up. But right now this is hidden. Why it is hidden? Because it is not needed. So By using the triangles, what can be done? By using the triangles, you can expand and look into in further detail. The size, color and angle of the triangles indicate the depth, number of nodes and the width of the summarized structure. Motive simplification applied to a network built from the Lostpedia website. The graph on the left is summarized in the graph on the right with arcs to represent the nodes that have singleton neighbors called fans, and many nodes that are linked to two of the discussion topics are summarized with an arc.